and review algebra stuff. Now, I know some people don't like to hear you should have learned this, but I'm going to say it anyways. Should have doesn't mean necessarily that you did because of COVID, okay? So I'm just trying to get you guys caught up too, because we don't say, okay, you're in algebra for 2 years. We move on to the next level, right? So the should have just means I'm going to try to get you caught up so you're not so far behind. Some of you, this will be a review. Some of you, this will be something brand new, okay? We'll spend all of our algebra stuff based on a week, if we have a regular week. So tests will be typically on Fridays. This one will be a little bit longer just because I know you haven't learned this. The reason why I'm pulling this up is because it's on the state tests that we take in the springtime, and I have a mixture of people, so I'm just trying to prepare those that are taking the SATs or any of that stuff, because this is on there, okay? This is considered trigonometry, which you would learn this when you go, if you had Mr. Carter, which I think he's finally retiring. So whoever takes his spot, I know, finally takes his spot, this would be something you would learn in it. And I know trigonometry seems like, oh my God, why is she doing this to us? I guarantee you, when you get done with this, you're going to look like this is easy, okay? Because pretty much your calculator does the whole thing for you. You just need to know which formula that you're using, okay? So this is why I said grab a calculator. So on your calculator, you should see the buttons sine, cosine, and tangent. If you don't, then you need to go grab one of my green and yellow ones that are over there, okay? It's sine, cosine, and tangent. Does anybody not have that one? You don't. Okay. It is. Okay. Okay, so the other thing is all calculators, we know this with the radical buttons. Some you just push the radicals, others you had to hit the second in this. So this first day, and possibly into tomorrow, it'll be you learning the calculator that you're going to use, okay? I will show you the steps for the green and yellow calculators. Some of your calculators are set up the same way. So what I'm showing you today, you're going to write those steps down so that you know how we got it. Then afterwards, I can come to you individually so that we can figure out your order of pushing buttons to get the same answer that's supposed to be the outcome, okay? So if you're not getting the answer, you might want to fiddle around with the order of things while I'm doing it, but otherwise it'll be after notes. I'll come to you and we'll mess with your calculator to figure out what the order is, okay? All right, so right now, you're writing this down. So SohCahToa is just kind of a way to start memorizing, like if you get to the state test and they don't have the formulas out there for you, how we memorize these formulas, okay? So it's kind of like, please excuse my dear Aunt Sally. Like, that's not really like a name of a math term that we use. This is a way for us to remember order of operations, okay? So SohCahToa is the same way. There's 3 formulas that we'll use. And the sine, cosine, and tangent have values attached to them, and we just don't memorize them because they're real long decimals, okay? It's kind of like hitting the pi button. Like, we remember 3.14, but it goes on forever, okay? And that's why they put a pi button on there for us, so we don't have to memorize that forever number, okay? This is automatically programmed into the calculators, okay? So that's what sine, cosine, and tangent. We actually have values attached to them. Okay, so you're writing this down. So SohCahToa, they're right triangles. This whole section has to do with right triangles. Okay, so drawing the 2 right triangles. Read my drawings here. Okay, and we learned previous to this section that the opposite side of the right angle is always the hypotenuse. So that shouldn't be anything new for you, right? Okay, and I just switched the drawing around, okay, so that you can learn that they don't always have to be facing the same direction. Okay, so same thing on this one over here. Okay, going opposite of the right angle is the hypotenuse. This symbol right here is called the theta symbol, which is just means the degree. Okay, so if we know a degree of this angle, okay, this one right here is called adjacent because it's next to it. But where this angle is on this one going this way. So if there was an angle, like say this was 45 degrees, okay? So next to the 45 degrees, this is the adjacent side because it's next to the angle. This one over here is opposite of the angle that we have. Okay, but this is always, always, always going to be the hypotenuse. So it's kind of like our a squared plus b squared equals c squared. The a and the b can switch. The c always stays the same. Okay, so kind of keep that in mind. So this is just a separate drawing now because now the theta or the angle measurement is not down at the bottom like it was on this one. It's up here at the top. Okay, so when it's up here at the top, this is still the hypotenuse. That doesn't change, but now this side is called the adjacent because it is next to the angle. And then this side is now going to be called the opposite. So what you need to look at in the drawing is where is the angle at? Okay, we'll know where the hypotenuse is, but the one that's next to it is either the adjacent, okay, or if it's down here, this would be the adjacent. So that's how we know the adjacent and opposite. Okay, and we're going to practice this again. This is something new to most of you. Okay, so I'm going to scroll this down so that you can write the difference between the opposite and the adjacent. And those are describing the sides. Okay, so these are our three formulas. So sine, cosine, and tangent. And remember, this symbol just means that if we had like 45 degrees, when we write the formula, we would just replace this with the 45 degrees. Okay, so sine of 45 degrees equals opposite over hypotenuse. Cosine of some degree is adjacent over hypotenuse, and then tangent of some degrees is opposite over adjacent. Okay, so where these formulas come from, and you've got it on your paper. I'm just going to go back to my previous screen. Okay, so you have the sine, cosine, and tangent. Those are the three buttons that are on your calculator. Okay, so that's where the sine and the cosine and the tangent comes from. Okay, these are the letters of the fraction. Okay, so the first one is the numerator. Okay, so O would stand for what? Opposite. H would stand for hypotenuse. So sine is opposite over hypotenuse. Okay. Cosine is going to be what on top? Adjacent over hypotenuse, and then tangent is opposite over adjacent. So that's just, it's just like PEMDAS, or please excuse my ignorance. It's just a way to memorize the formulas. Okay. And again, hypotenuse is always the long side of the right triangle. Okay. So, and now we're going to actually see how we apply these to some of the problems that we're going to be doing. Okay, so this isn't too bad. Like, you just need to know which numbers and which formula you're plugging in, and then you're just typing, you know, the top number divided by the bottom number and hitting sine, cosine, or tangent. Okay, really not just a matter of knowing which one to use. Okay, so we are starting. This is problem number 20. I'm going to give you a sheet, but I don't want to give it to you now because otherwise you won't be paying attention to me. You'll be looking at the worksheet. So this is problem number 21. Okay, and I just want you to draw a sketch of a right triangle. It doesn't have to be flipped this way. Okay, it can be whatever right triangle you want it to look like. It can be flipped going the other direction. Okay, so this is problem number 21. Okay, so when you get the worksheets, it says a ladder is 12 feet long and makes an angle of 63 degrees with the ground as it leans against a store. How far up the store does the ladder reach? Okay, so what do you think in relationship to the store, the ladder, and the ground? What do you think this part represents? The ground, right? Okay, so this would represent the ladder, and this would represent the store, the height of the store, right? Okay, so I'm filling in, like, and again, it doesn't matter if your drawing's flipped around the other way, you're still going to have a bottom, a leaning, and then, so you're just drawing the representation so we can start filling things in. Okay, so the first part says a ladder is 12 feet long. So where am I putting that? On the hypotenuse. Good. Okay, so really this is 12. Okay, so whatever direction, you're going to put 12 on the hypotenuse, okay? It makes an angle of 63 degrees with the ground. Okay, so that means here's the ground, and it makes an angle with the ground, which is 63 degrees. Okay, so we're just filling in what we have so we know which formula we're going to use. Okay, so it says a ladder is 12 feet long, makes an angle of 63 with the ground as it leans up against a store. How far up the store does the ladder reach? Okay, so how far up the store does the ladder reach? So this is the one we're trying to find, okay? Okay, so what we're looking at is we're given one in relationship to that angle, and we're finding one so that we know which formula we're solving for, okay? So this one is the theta, right? This is the angle thing. This is called the hypotenuse. Okay, so I'm just going to label this hypotenuse. And the angle, or the side that we're trying to find, is either adjacent or opposite. 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 Okay, so we're going to label. Okay, so I know in your notes you have it. I will have it, because you won't always want to go back and look at your notes. I have it written on the board over there. Okay, so we're looking for hypotenuse and opposite. So which one has hypotenuse and opposite? Sine. Everybody see that? Okay, or on your notes, see that? Okay, so this is the way we write the formula. Okay, so it's sine, and remember it's theta, so it's the degree that they gave us, which is what? 63. We're just writing it so we know how to set it up. Okay, and then what goes on top in your formula? What is the formula? We're using sine, so what's on top? Opposite. Do we know opposite? No, so that's the one we're trying to solve for. And it doesn't matter, I put an X just because we don't know it, it's a variable. Okay. And then on the bottom was the hypotenuse. What was the hypotenuse? 12. Okay, so we're using algebra, the buttons on our calculator, to solve for X. Okay. So if I want to get X by itself, what do I do with that 12? Times it by 12, right? Because right now it's X divided by 12, so to get rid of the 12, we do the opposite, right, in algebra. So to get rid of it, I want to times it by 12. So really, I'm just taking the 12 over to this side, right, and timesing it by 12. Because if we did it on this side, it gets rid of it, right? That's the whole purpose, to get the X by itself. Okay, so now this is when we get to start pushing buttons, and we're going to practice it on yours as well. This is the order for the green and yellow calculators, okay? And I'm going to do like push this button, push this button, push this button. You're writing it out steps until you get used to this, okay? So the first thing on the green and yellow calculators is you are going to type the number 63 in. Okay. Then you're going to hit the send button. Yes, you get to send in class. Excited, buddy?
Trying to do it.
Then you're going to hit the times button. Guess what's next? 12. And then you actually have to hit the equals, so it's a little off. Okay, tell me what you got. For those that have the green and yellow. Yep.
10.6.
Yep. Okay, so you should get, as the proper answer, 10.69. I will let you know whether you're going to the hundreds or the tenths, just because they kind of go back and forth. Sometimes they don't specify. So I'll tell you when we go to do an assignment, everybody just go 1 decimal spot or 2 decimal spots. Okay, that should be what you got. So if you didn't get that with a different calculator, you might have to go to a different order. Okay, you might have to hit the 12 times 63 sin, or 12 times sin 63. Some of your calculators put in parentheses for you. So if that's the case, the sin is attached to 63. That would be the one that you would put in parentheses. So try that. Pause for a second just so you can kind of mess with it. If not, then I will come to you when we get done with this to make sure that you are. Okay, so the next problem is number 22. Go ahead and draw a sketch. Okay, Okay, this time on the worksheet, they actually had a sketch there for you, okay, and they put letters on there versus writing it out in a sentence and telling you where to put them. Okay, so if you have it flipped, that's okay, just know this is, down here is gonna be the A and the C, okay? So A, C, and B.
Doesn't matter which order A and C is in.
C needs to be at the right triangle. Okay, and the reason why, just getting in a habit of it, is remember when we did the Pythagorean theorem, it was a squared plus b squared equals c squared. They will have big A's and little a's, and big B's and little c's. And so wherever you put your A or your B, going opposite of it will be the little letter. So like this would be little b, okay? And this one would be little a. Now those two can flip, like it does in the Pythagorean theorem, but C is always the hypotenuse, so C always needs to be the right triangle, or the right, if that makes sense. Okay, but the A and the B can flip. Okay, so they had that labeled, and then they have a 4 here, a 5 here, and a 3 here. Okay, and this is what it says in the sentence, because they actually tell you which formula you're using. It says find tan B for the right triangle below. Okay, so tan B means you do not know the what? The degrees. That's what we're finding. Okay, so we know we're using tangent. Okay, so we're going to go ahead and write the formula. So tangent, I don't know what it is, and they use the letter B. You can put the theta symbol. It doesn't matter, but we're solving for the angle measurement. Okay, so tangent is what over what? Opposite over adjacent. Okay, so we're just writing this so we know which formula we're using. Okay, so really, can be means we're finding this angle right here. That's the one that we're finding, okay, because we don't know that. Okay, so which number is opposite of B? 4. Okay, so we're filling in. Because remember, we don't know the angle measurement. That's the part that we're trying to find out. But opposite of B is the number 4. Okay, in relationship to B, which one is adjacent? The 3, because 5 is the what? Hypotenuse. And that's not in the formula, so we're using 3. So it's just a matter of knowing what you're putting where. Okay, we good up to that point. Okay, so because we're finding angle measurement, you're going to be using a second button. So again, these are the steps for the green and the yellow calculator. I'll pause it so you can mess with it to make sure you get this answer if you have a different calculator, okay? So 4 is being what by 3? Divided by 3. So we're going to go 4, hit that button on your calculator, divided by 3. Okay, and then you're going to hit the equal button. And then for some of you, it's a shift button, others it's a second button. So on the green and yellow calculators, I believe it's a second button. And then you're going to hit the tangent button. Okay, some of you, the second button looks like this. It has a tan, and it looks like this. That's the one that you're going for. It's the tangent button, but it's going to the one up above it that says tan negative 1. Okay, so those that have green and yellow, what'd you get?
53.13.
Yep. Okay, so you're aiming for 53.13. If you have a different calculator, that is the correct answer. This one we're going to solve for all the missing parts. They're going to tell us parts of it, and then we're going to apply everything in more than one formula to find all of the parts. Okay? So number 23, it says solve the right triangle given that capital A is 60, capital C is 90. So that means that this, right, is the C. Okay, so that one has to be that one. Okay, and that's 90 degrees, which we know that because it's a right triangle. And then it does not matter if you want to put A here or A down here. Does not matter. You're still going to get the same answer. I'm going to put it up here. Again, it does not matter. This one is the one that matters, okay, because that's the one that's opposite of your right angle, okay? So capital A, whether you have it up here or down here, is 60 degrees. Okay, and then it says little a is 17. So if your A is down here, then that means, remember I said opposite side, your little a will be here. I put mine at the top, so it's always opposite. So this is going to be my little a, which is down here, you said is 17.
So wait, why is it down there?
It's always on the opposite, because remember, if this is C, and this has to be C, okay, in Pythagorean theorem, when we had it, remember it was a squared plus b squared equals c squared, and C is always the what?
For the right
What's this called?
hypotenuse.
Hypotenuse. So that means opposite, right? Big C and little c, because if you were to solve for a squared plus b squared equals c squared, this has to be your C. So it's opposite of, it's a big letter and a small letter. Like the angles are big letters and the sides are small letters.
Okay.
Okay, so wherever you put your A, because it could be down here, and you'll still get the right answer. If you have A here, then you're putting it your 17 over here.
Okay.
Okay, I put it on top, so it's done. Okay, so this is all we know, but we got to solve for it. They want you to solve for all the sides and all the angles. Well, previous to this, without using those formulas, there's a way to find that third angle. If I know one is 60, one is 90, how could I find B?
Track the add them together and subtract them by 180.
Good, right? Because all triangles, regardless of what triangle, is going to be 180. Okay, so if you add 90 and 60 and subtract that from 180, what did you get?
30.
What was the answer for B? 30, right? Because you would add these two and get 150 and subtract from 180 would be 30. Okay, so this one's 30. Okay, because they all add to equal 180. Okay, so now we're going to look for the missing sides. So I'm going to start with this one, okay, because that was the one that they gave us. Okay, remember there's always one they give us. So they gave me, in relationship to this one, is called the opposite. Okay, I'm going to, yeah, I did this one. Okay. So this one right here, I'm going to solve for this because I have to solve for that one too. It really doesn't matter. I'm just going to go to this one right here. So in relationship to this angle, that is called the opposite. This is called the hypotenuse. So which one has opposite and hypotenuse? Sine, right? Or sin. Okay. So we're going to write sin. I know the angle measurement because we used 60. Okay. On sin, what is on top? Opposite, right? And opposite they gave me, so that number has a number, not an x, okay? And then on sin or sine, on the bottom is hypotenuse, and that's the one that I don't know. Okay, and again, you could put a little c there if you want to, or an x. That just means that we're solving for what's missing, the variable that's missing. Okay, so this is opposite of what we had before. Before we had to get the c or the x was on top, so we took the 17 to the other side. Okay, we still need to get the c by itself, but first I need to get everything moved, right? So when I had a number here, to get this by itself, I took it over here, right? That still doesn't get the c by itself, but I'm just going to write it because it makes it easier to see where it comes from. No, not intended. Okay, when I take the c to this side, c is still not by itself, but this is times, right? So opposite of times is to divide. So if I want to get the c by itself, that would mean I need to divide by sin 60, and what I do to one side, I've got to do to the other side. So really, when you have ones with this down below, this just goes down here, and this comes up here. Okay, it's just division, because right here is multiplication, but c is not by itself, so we divide by sin 60, and what I do to one side, then I've got to write on the other side. Okay? Okay, we're good? So if there's a variable on the top, we know we're multiplying. If the variable is on the bottom, we're going to end up dividing. Okay, so this is the order that we're going to do to solve it. Okay, this again is the green and the yellow calculators. So it's 17, this being divided by, okay, and then we hit 60 first, and then sin, and then equals. Green and yellow calculators. Tell me what you got. Yep. Okay, I got 19.63, but 62 would be probably the number next to it, maybe. It might have been bigger, so I rounded up. Yeah, yeah. Okay, so other calculators. You probably can hit the send button first, and then in parentheses go 17 divided by 60 and equals. Try that. So that the 17 divided by 60 is in parentheses and sin. It didn't work. Okay, let me pause that. Mess with that one on your wrist.